to the next talk. And it's about natural durability of Indian timber towards Microtermes obesis termites, with a special reference to a special type of trees. And the talk is going to be given by Mrs. Upasna Sharma. She's a third-year PhD student. So it's always a pleasure to have you as a speaker, but I think we'll leave the floor to Mrs. Sharma for our presentation. And you've got 20 minutes, and then we'll have question and answers.
Hello, everyone. Good morning, good afternoon, and good evening. My name is Upasna Sharma from Forest Research Institute, Dehradun, India. And today, I'll be talking about the natural durability of Indian timbers towards Microtermes obesi with special reference to Artocarpus species. So, this is the outline of my presentation. I'll be talking about the introduction, under which I'll be discussing about the classification, distribution of the timber species, about the current study, which is a case study, picture illustrations, timber examination, insect identification, and then some key points, and then conclusions. The current study deals with the invasiveness of termite infestation in timber of Artocarpus sharma. It furnishes the anatomical structure of Artocarpus sharma as a cause for termite invasion. It also reflects upon the natural durability of the hardwood of 23 Indian timbers against a specific termite, which is essential for making practical and wise use of wood. Artocarpus sharma is commonly known as chamkathal in SMAs, and according to the recent system of classification, which is APG 6 2016, it belongs to the Angiosperms and family Moraceae. Artocarpus sharma, also known as Artocarpus chaplasha, is a tall deciduous tree with an average height of 30 to 36 meter and girth of 3 to 4 meter. The timber is commercially very important and is extensively used for shipbuilding, dugouts, canoes, masts, and oars, for house building as beams, wall plates, scantling doors, window frames, and boarding, for furniture and carts, and especially wheelwrights work in bodies as frames, panels, and footboards, for carving in Assam, and by the ordnance departments for general purposes and packing cases. Therefore, it is a sound timber species to be encouraged and worth planting and protecting. This is the distribution map of the Artocarpus sharma. It is native to Andaman Islands, Assam, Bangladesh, China, South Central, and East Himalaya. The distribution is extended in sub-Himalayan tract, Nepal, and other parts of East Asia. So, this is the pictorial demonstration of the current study, which is a case study. In this, a number of sackful containing authentic wood hand samples of Indian hardwoods and softwoods were stored and checked for their wellness in the store of Xylarium FRI Dehradun. Only one sackful, marked here with red, was found to be infected, and we further examined the infected sackful. On further investigation, we observed that the sackful was containing 396 authentic wood samples belonging to 34 Indian timbers, and out of 396, 74 samples were that of Artocarpus sharma. We separated the intact and infected samples. 297 samples out of 396 were intact and 99 samples were infected. Out of the 99, 69 samples were that of Artocarpus sharma, which means that 70% of the infected samples belong to Artocarpus sharma, and 93% samples of the Artocarpus sharma were infected. This is the table enlisting Indian timbers sharing the same environment with that of Artocarpus sharma. As we can see that there were 77 samples of Anthocephalus, out of which 67 were intact, 55 samples of Aphanomyxis, out of which 52 were intact, 21 samples of Antidesma, and none of them were infected, and 22 samples of Abyssinia officinalis, and none of them were infected. There were also 14 samples of Artocarpus heterophylla, and all of them were intact. So we were interviewed with the observation of susceptibility of Artocarpus Sharma towards specific termite. Therefore, we further investigated the cause of termite invasion on the specific timber species. These are the picture illustrations of the infected samples. In the first and second picture, we can see the infected and intact samples and along with the insect debris. And in the third picture, we can see the infected samples. The wood was so severely attacked that the samples were looking like bones. In this slide, we can see the large number of separated infected samples of Artocarpus sharma, and we also observed that the samples were attacked from the side where they were marked with the marker. Therefore, we presume that the ink of mark might have served as an attractant for the termite. The third picture illustrates the backside of the above sample, and here it could be seen that the samples are in a better state than they are in the second picture. To investigate the cause behind invasiveness of termite on Artocarpus sharma wood samples, we went deep down to study the anatomical features of samples to check if the insect attack could be attributed to sapwood, as sapwood may contain moistures or chemicals suitable for parasitic growth. Also, the anatomical features postulates the physiological behaviors of trees. Therefore, we examined the infected wood sample. For this, two wood blocks were prepared from the infected samples. They were boiled to soften the tissue. Thin sections of 30 to 35 micrometers were cut on the Richard microtome, and they were mounted with glycerine and examined under light microscope. From the transverse sections of the Artocarpus sharma, tyloses were clearly reported. Therefore, it becomes evident that the samples were that of hardwood and not that of sapwood, and the insect attack could not be attributed to sapwood. We also observed some hook-like structures in the vessels, which I would discuss later. We failed to report the termite on spot. Therefore, for insect identification, we prepared the microscopic slides from the debris covering wood samples. Microscopic examination of the insect was done and snapped using scope A1 Exio equipped with Carl Zeiss camera. The hook-like structures we observed in the samples of Artocarpus sharma was also observed from the slides prepared from the debris and was found to be the mandibles of the termite, which were encarved. We also observed the head capsule, which was oval in shape. Therefore, Microtermes obesi of family Termitidae was identified that invaded wood samples of Artocarpus sharma. It has a wide range of hosts, varying from germinating wheat seedlings, ripening wheat and maize seedlings, and tea-growing areas of Verak Valley of southern Assam. Host range of trees include Dalbergia siso, Malayana arborea, Mangifera indica, Pterocarpus marsupium, Shoria robusta, Tectona grandis, and Terminalia lata. The termite is distributed in Bangladesh, India, Myanmar, Pakistan, and Thailand. I would like to add some key points from the previous literature related to the current study, which would shed some light on the study. It has been reported that the reflex and radial latex ducts are present only in Artocarpus sharma. These features are peculiar to Artocarpus sharma wood, as they are absent in other studied Artocarpus species such as Artocarpus heterophyllus, Artocarpus lacucha, and Artocarpus nitridus. In the same study, most ample proportion of vessels, which is 30%, and hence tyloses, and least abundant proportion of parenchyma, which is 12%, were also observed in Artocarpus sharma among the 4 species. We observed that an infestation of wood samples begin from the side where samples were marked for identification. A true wooden block reveals the radial entry of parasite inside the wood tissue, which must be for latex as food for insect from the radial ducts of Artocarpus sharma. Bioactive studies on leaves of Artocarpus sharma crude methanol extracts revealed mild to moderate antimicrobial activity of the Artocarpus sharma, therefore strongly provisions the current study. While concluding, we can say that it was not the ink of marker that acted as attractant to the termite. Rather, it was the exudates or secretions possessed by Artocarpus sharma which served as an attractant to the termite. Resistant towards termites attack by other species of Artocarpus, especially Artocarpus heterophyllus, is ascribed to the termicidal activity shown due to artocarpine drug produced by the heartwood of Artocarpus heterophylla. Even after the availability of sufficient food, as illustrated through a table, the termite chose to invade Artocarpus sharma samples only. Therefore, the current study concludes the Microtermes obesi as a serious termite of Artocarpus sharma timber. The findings are helpful in processing and seasoning of timber to maintain the durability. The observations have also implications in maintaining biological diversity of Artocarpus sharma against the reported termite. Out of 34 Indian timbers, 23 timber species were found to have with no number or zero number of infected samples. Therefore, hardwood of these timber species exhibited a considerable resistance to termite attack and is ascribed to their anatomical and biochemical properties. As a result, understanding natural termite resistance of wood is critical for making sensible and wise use of wood. We did not study infected wood samples other than Artocarpus sharma because a few samples were infected and sufficient number of infected samples were not available to derive a conclusion about them. So it could not be predicted that 10 timber species other than Artocarpus sharma were infected with Microtermes obesi or by some other species of termite. We graded the samples of the sackful. We separated the infected samples and the intact samples. All the samples of attacked sackful, that is intact and infected, were fumigated with carbon disulfide for further storage. These are the picture illustrations of the samples under fumigation. In the first picture, the intact samples were kept for fumigation, and in the second picture, the infected samples were kept under fumigation with carbon disulfide for further storage. Thus, I wish to end my today's presentation with one of the Douglas Mallock quote, which states as, "The tree that never had to fight for sun and sky and air and light, but stood out in the open plain and always got its share of rain, never became a forest king, but lived and died a scrubby thing. Good timber doesn't grow with ease. The stronger the wind, the stronger the trees." Thank you. Thank you for having me.
Thank you very much.